Let me start with a very common site situation. You go to a slab, and you see a straight crack running across it. The contractor tells you, "Sir, slab design to correct tha." But still, the crack is there. Now the question is, why does this happen? In many cases, the real reason is improper hidden beam design or execution. So in today's session, I will explain hidden beam sizing and design in a very simple and practical way, so that you, as an engineer, can actually avoid these problems on site. First, let us clearly understand what a hidden beam is. A hidden beam is basically a beam, but its depth is kept equal to the slab thickness. Because of this, it is not visible separately, it looks like part of the slab itself. Now where do we use hidden beams? We generally use them to support partition walls, to maintain a flat ceiling appearance, in small span residential structures. But here is the important point. Just because the beam is hidden, does not mean it is structurally less important. In fact, it is still carrying load but with a limitation of smaller depth. Now let us understand what IS codes say about this. In IS 456, you will not find a direct term called hidden beam. But that does not mean it is not covered. We have to design hidden beams using the same principles as beams and slabs. Now there are three very important considerations you must always remember. First is deflection control. Since the depth of a hidden beam is very small, its stiffness is also low. And when stiffness is low, deflection increases. That is why IS 456 gives span to depth ratio guidelines. To ensure that the beam does not bend excessively under load, refer my video on beam sizing. Link given in description. Second is minimum reinforcement requirement. As per clause 26 of IS 456, we must provide minimum steel, so that the member does not fail suddenly and can resist cracking. This is especially important in hidden beams, because their concrete section is already limited. Third is cover and detailing for durability. Proper cover ensures that reinforcement does not corrode, and proper detailing ensures that forces are safely transferred. So even though hidden beam looks simple, its design must strictly follow IS code provisions. Now let us understand how hidden beam actually works. Imagine a slab with load acting on it. This load is first carried by the slab, and then transferred to the hidden beam. From the hidden beam, the load goes to columns or main beams. So the load path is slab to hidden beam to column or main beam. Now here comes the problem. Since the beam depth is equal to slab thickness, its ability to resist bending is limited. In simple terms, a deeper beam is stronger, and a shallow beam is weaker. So in hidden beams, depth is fixed. Strength must be increased using reinforcement. That is why we generally increase steel percentage, ensure proper anchorage, maintain adequate width, usually around 200 to 300 mm. You can think of hidden beam as a compromise element. Architectural requirement demands less depth, so structurally we compensate by better design and detailing. Now let us take a simple example so you can understand design easily. Suppose we have a hidden beam with a span of 3 meters. The slab thickness is 150 mm and beam width is 230 mm. We are using M20 concrete and Fe 415 steel. Now first step is load calculation. The self-weight of slab is calculated as thickness multiplied by unit weight. So 0.15 meter multiplied by 25 gives us about 3.75 kilonewtons per square meter. Now if we include flow finish and live load, we can assume total load is approximately 6 kilonewtons per square meter. Now this load is transferred to the beam. If tributary width is 2 meters, then load on beam becomes 6 multiplied by 2, which is 12 kilonewtons per meter. Next, we calculate bending moment. For a simply supported beam, maximum moment is given by WL square divided by 8. So putting values 12 multiplied by 3 square divided by 8, we get approximately 13.5 kilonewton meter. Now comes steel design. Since the total depth is 150 mm, effective depth will be around 120 to 125 mm after cover. Because depth is small, required steel will be comparatively higher. So in this case, we can provide 2 12 mm bars at bottom, 2 10 mm bars at top, and 8 mm stirrups at 150 mm spacing. But always remember, this is a simplified explanation. On real projects, proper design calculations must be done. Now let's talk about what actually goes wrong on site. First problem is cracks in slab. This usually happens when hidden beam reinforcement is insufficient, or when beam is not properly designed for deflection. Second problem is improper bar placement. During concreting, if bars are not tied properly, they shift from their position, and the beam loses its strength. Third issue is reduction in slab thickness. Sometimes due to poor shuttering, actual depth becomes less than design, and that directly reduces beam capacity. Fourth issue is shuttering alignment. If beam location is not marked properly, it may not come exactly where required. Fifth issue is lack of coordination. Sometimes drawings are not followed properly, or hidden beams are missed completely. Now let me give you some very practical site tips. Before concreting, always check beam marking on shuttering. Do not assume, physically verify. Make sure reinforcement cage is properly tied, so that it does not move during pouring. Check cover blocks, because improper cover can lead to durability issues. Ensure slab thickness is maintained. Never allow unauthorized reduction. Also check levels and alignment of shuttering. And finally, always cross-check with structural drawings. If you follow this checklist, most hidden beam problems can be avoided. So let's quickly summarize. Hidden beam may look like part of slab, but structurally it behaves like a beam. Its biggest limitation is small depth. And that is why design and detailing become very important. If you ignore hidden beam design, you will definitely face cracks and serviceability issues on site. So always design carefully and execute even more carefully. If this explanation helped you understand the concept clearly, do like the video, subscribe to the channel, and feel free to ask your doubts in the comments.